Now moving on to the question number 1, find the rule which gives the number of matchsticks required to make the following matchstick patterns. Use a variable to write the rule. First bit, a pattern of letter T. Now moving on to the solution. Now let us find the solution for the A bit. In the A bit, they have asked us to find the rule to make a pattern of letter T. Here we require two matchsticks to make a pattern of letter T. Here now let us construct a one pattern of letter T. That is, we require two matchsticks, and to make a pattern of two letters T we require four matchsticks, and three patterns of letter T we require three matchsticks, and so on continuous. Now let us construct a table using this. Here in the first column we take number of T's we have to form, and in the second column number of matchsticks required to make a pattern of letter T's. So by observing this, to make one pattern of letter T we require two matchsticks. So in the first column we write, to make one pattern of letter T we require two matchsticks, and to make two patterns of letter T we require four matchsticks, and to make three patterns of letter T we require six matchsticks, and so on. For making four patterns of letter T we require 8 matchsticks, and so on. So by considering the above table, we can tell that the number of matchsticks required is equals to, by considering this table, we can tell that 2 into number of T's formed, which is equals to 2 into n. Here n is a variable. A variable is something that can vary. Its value is not fixed. We can take any different value, that is n is equals to 1, 2, 3 and so on. By substituting n is equals to 1, we get 2 matchsticks, and substituting 2 we get 4 matchsticks, and so on. So the number of matchsticks required is equals to 2n. Now moving on to the B bit, here they have asked us to find out the rule for a pattern of letter Z. Now moving on to the solution. To construct a pattern of letter Z, we require 3 matchsticks. We require 3 matchsticks to make a pattern of letter Z. Now let us construct one letter Z. We require 3 matchsticks, and constructing 2 patterns of letter Z, we get 6 matchsticks, and 3 patterns of letter Z, we get 9 matchsticks. So by using this, constructing the table, in the first column we write it down as number of Z's formed, and in the second column number of matchsticks were taken. Here to make a pattern of one letter Z, that is n is equals to 1, we get 3 matchsticks, and 2 patterns of letter Z, we get 6 matchsticks, and 3 patterns of letter Z, we get 9 matchsticks, and similarly 4 we get 12 matchsticks. So by considering this table, we can write number of matchsticks required is equals to 3 into number of Z's formed, so which is equals to 3 into n. Here n denotes a variable. A variable is a value, something that can change. its value is not fixed. It can take any different values, that is n is equals to 1, 2, 3, 4 and so on. So the number of matchsticks required to make a pattern of letter Z is equals to 3n. Now moving on to the C bit, here they have asked us to find out the rule for a pattern of letter U. Now moving on to the solution for the C bit. Here, to construct a pattern of letter U, we require 3 matchsticks. We require 3 matchsticks to make a pattern of letter U. Letter U. Now finding the rule for the given pattern, we require 3 matchsticks to make one pattern of letter U, and we require 6 matchsticks to make a pattern, to make 2 patterns of letter U, and we require 9 matchsticks to make 3 patterns of letter U. So considering this, constructing the table, we get, in the first column we write number of U's were found, and in the second column number of matchsticks required to make a patterns of letter U. So to make one pattern of letter U, we require 3 matchsticks, and to make 2 patterns we require 6 matchsticks, and 3 patterns we require 9 matchsticks, and similarly 4 patterns we require 12 matchsticks. So from the above table we can tell that number of matchsticks required is equals to 3 into number of U's formed. So which is equals to 3 into n. Here n denotes a variable. Variable is a value, something that can change. Its value is not fixed. It can take any different values like 1, 2, 3, 4 and so on. So the number of matchsticks required to make a pattern of letter U is equals to 3n. Now moving on to the D bit, a pattern of letter V. A pattern of letter V. So to make a pattern of letter V, we require 2 matchsticks. So we require 2 matchsticks to make a pattern of letter V. Now finding the rule to make a pattern, first let us construct one pattern, that is we require 2 matchsticks, and constructing 2 patterns we require 4 matchsticks, and 3 patterns we require 6 number of matchsticks. So using this, constructing a table, we get, in the first column we take number of V's formed, and in the second column number of matchsticks required to make a patterns. So for one pattern we require 2 matchsticks, and for 2 patterns we require 4 matchsticks, and for 3 patterns we require 6 matchsticks, and 4 patterns we require 8 matchsticks. So by using this, we can tell that number of matchsticks required is equals to 2 into number of V's formed, which is equals to 2 into n. Here n denotes a variable. Its value is not fixed. It can take any value, that is 1, 2, 3 and so on. So the number of matchsticks required to make a pattern of letter V is equals to 2n. Now moving on to the E bit. Here we have to find out a rule for a pattern of letter E. Now moving on to the solution for this. To make a pattern of letter E, we require 5 matchsticks. We require 5 matchsticks to make a pattern of letter E. Now let us find the rule for this pattern. Here to construct a one pattern of letter E, we require 5 matchsticks, and 2 patterns of letter E, we require 10 matchsticks, and to make 3 patterns of letter E, we require 15 matchsticks. Now using this rule, constructing the table, in the first column we take down as number of E's formed, and in the second column we take number of matchsticks required to make the patterns. So by using the above rule, for making the one pattern we require 5 matchsticks, and for 2 patterns we require 10 matchsticks, and for 3 patterns we require 15 matchsticks, and for making 4 patterns we require 20 matchsticks. So by observing the above table, we can tell that number of matchsticks required is equals to 5 into number of E's were formed, which is equals to 5 into n. Here n denotes a variable. Its value is not fixed. It can take any different values, that is 1, 2, 3 and so on. Here by substituting n is equals to 1, for making one pattern we get 5, and for making 2 patterns substituting 2 we get 10 patterns, and so on similarly. So the number of matchsticks required for making a pattern of letter E is equals to 5n. Now moving on to the F bit, here they have asked us to find the rule for making a pattern of letter S. So finding the solution for the F bit, to make a pattern of letter S, we require 5 matchsticks. We require 5 matchsticks to make a pattern of letter S. Now finding the rule for the pattern of letter S, for making one pattern of letter S we require 5 matchsticks, and for making 2 patterns we require 10 matchsticks, and similarly for making 3 patterns of letter S we require 15 matchsticks. So considering this rule and constructing the table, we get. Now moving on to the G bit, here they have asked us to find the rule for making a pattern of letter R. Now let us find the solution for this. Here we require 6 matchsticks to make a pattern of letter R. Now let us find the rule for making a pattern. Here for making one pattern we require 6 matchsticks, and for making 2 patterns of letter R we require 12 matchsticks, and so on. By using this rule, constructing the table, we get, in the first column we take down as number of patterns were formed, and in the second column number of matchsticks required. So for making one pattern we require 6 matchsticks, and for making 2 patterns we require 12 matchsticks, and for 3 it's 18, and for 4 24 matchsticks. So by observing the above data, we can tell that number of matchsticks formed is equals to 6 into number of patterns were formed, which is equals to 6 into n. Here n denotes a variable. A variable is something that can change. Its value is not fixed. It can take any different values, that is 1, 2, 3 and so on. Here for making one pattern, substituting n is equals to 1, we get the number of matchsticks as 6, and substituting 2 for making two patterns, we get the number of matchsticks as 12 and so on. So the number of matchsticks required to make a pattern of letter R is equals to 6n. Now moving on to the question number 11. A bit, look at the following matchstick pattern of squares. The squares are not separate. Two neighboring squares have a common matchstick. Observe the patterns and find the rule that gives the number of matchsticks. So moving on to the solution. When we observe that the given matchstick pattern, the number of matchsticks in one square was 4 and the two squares are combined and the number of matchsticks was 7 and here 10. So when we observe that the number of matchsticks were 4, 7, 10 and 13, which is one more than the thrice of number of squares in a pattern. Hence the pattern is 3n plus 1. Here n is a variable. By substituting n is equals to 1, we get 4 number of matchsticks, and substituting n is equals to 2, we get 7 number of matchsticks, and similarly so on. Hence the rule for this is 3n plus 1, where n denotes the number of squares. Now moving on to the B bit. This figure gives a matchstick pattern of triangles as in exercise 11a above. Find the general rule that gives the number of matchsticks in terms of the number of triangles. So moving on to the solution. When we look at the above pattern, here the first triangle contains 3 number of matchsticks and the second two triangles were combined which contains 5 number of matchsticks, and in the third figure 3 triangles are combined and we get 7 number of matchsticks and so on. So when we observe that the given matchstick pattern, so the number of matchsticks are 3, 5, 7 and 9, which is more than the twice of number of triangles pattern. Hence the rule for the pattern is 2n plus 1, where n denotes the number of triangles. By substituting n is equals to 1, we get 3 number of matchsticks for one triangle, and substituting n is equals to 2 for two triangles, we get 5 number of matchsticks. So the rule for this is 2n plus 1.